So far we have done until this part. Now the portion we are talking about will be the uncertain part, or the part which is like the 20%. Why is not exact? Why this is not the answer? Let's do another part, which is y equals to, let's say, x to the power n plus 1. Differentiating this, we get a result of what? N plus 1 x to the power n, isn't it? Now let's give us another function, which is y equals x to the power n plus 1. Let's say we have a variable, like a constant added to it, which is 100. Differentiate this. What should we get? Try it by yourself. Pause the video and try it by yourself. So it should be x to the power n plus 1. Sorry. It should be n plus 1 times x to the power n. Now, this 100 means what? There is an imaginary x to the power 0 there. So 100 times that power comes in front, so 0 times x to the power 0 minus 1. And anything to the power 0, anything multiplied with 0 becomes what? 0. That means the dy by dx of this expression is also n plus 1 x to the power n. Now, let's do another one, which is y equals to x n plus 1 minus, let's say, some k. K is a constant here. So k means there is a x to the power 0 here, imaginary. So y equals to x to the power n plus 1, sorry, dy by dx equals to n plus 1 x to the power n plus 1 minus k, and here what happens, the power comes in front, times x to the power 0 minus 1. Now here, see, anything, like 0 is multiplied with this expression. So anything times 0 means what? 0. So this also gives us a value of 0. That means dy by dx of this function, of this equation, is also n plus 1 x to the power n plus 1. Sorry, x to the power n, not n plus 1. My bad. Yeah, x to the power n. So that means now for the three different equation, we got the same exact result. Now, integrating this result, which of these functions should we get then? Which one is the correct answer? Like, isn't it the question? Like, integrate, if we integrate this function, like this dy by dx now, should we get this one or this one or this one? Like, how should we know? Like, dy by dx equals to n plus 1 x to the power n. From which of these function did we get? Isn't it? It could also be like some other value as well. Like, if instead of, let's say, like with this, let's say 100x, 100, like 100, if there is, let's say, or like simply with this y equals to x to the power n plus 1 initial function, let's say if there was some other constant added, k plus 5 plus a, something like some other constants were added. Like, how do we know, like, whether that was the initial function or these are the initial function? Like, how are we supposed to know? Isn't it? Because from one result, integrating them, there's a, like, we are getting to this common point from different results, isn't it? From different point of, like, points, we are getting this result. Then which one is the correct result, or which one is the correct answer? What should you do? Isn't it a confusing thing? Okay, let's explain this a bit. Let's say we have a straight line. This is, let's say, y goes to this, and y-intercept is, let's say, 2. So y goes to x plus 2 is the equation here. Okay. Another equation is, let's say, this is passing through the origin, and this has the equation y goes to x. Okay. Another equation is, let's say, this is, the y-intercept, let's say, minus 10. So this equation is y goes to x minus 10. Can you find the gradient of each of this equation? don't like overthink, just use the normal formula. Remember, what is the straight line equation? Y equals to mx plus c, where c is the y-intercept, and m is what? The gradient. That means the slope value, the rate of change of y with respect to x. Okay, that's what m means. So we have to simply find that m value. Now compare this equation with this individual equation and try to find, like we are doing equating coefficient. Okay, so here we have what? Y equals to x plus 2, one of the equation. Another one is y equals to x, and there should be a c. So here, since we know the y-intercept is what? 0 here. So that means the c is actually 0 here. So writing 0 and not writing 0 is like same thing. So that's why like the simpler form is to write y equals to x, but for the simplicity, we will write y equals to x plus 0 to have the equivalency of this equation. And the other equation is what? Y equals to x minus 10. Now see here, like the x is simply just there standing by itself. There's no like other coefficient added, like written here. Coefficient means a value at the front. So the coefficient of x here, like the coefficient of x here is m. So 4 is the coefficient of x. Like if 4 is written in front of x, 4 multiplied with x, so that's the coefficient. Now, if nothing is written, that means what? The coefficient is what? Actually a 1. There's an imaginary 1 there. So can you find each of these equations gradient? The gradient to this equation is what? Like simply compare this. Y is in y's place, x in his x's place, and c is in c's place. Like c is equivalent to what? 2 here, and this here it is equivalent to 0. That means the y-intercept for this equation is 0. The y-intercept for this equation is 2. The y-intercept for this equation is what? Minus 10, which actually could be like defined from this graph as well, from the sketch as well. And see from here, what's the m value? Just simply like do equating coefficient. This is known as the equating coefficient. That means we're comparing the equation. Like at first, we're like in order to do comparison, let's say we're comparing between two students. They actually like the first thing is what? They have to be in the same class. They have to take the same subjects. They have to give same exams. Then we will compare how well they did like in the exam, isn't it? Or how well good they are in study. So that's how like something. Or let's say if we have to compare two things. Let's say two cars we're comparing. We have to compare, let's say, like same engine capacity. Like at first they have to be have same like, constants. Let's say they have to be a car, not a motorbike and a car. We cannot compare a motorbike with a car. We cannot compare an airplane with a car. We cannot compare a CNG or a 3-wheeler with a 4-wheeler, like that sort of thing. We have to keep certain things constants and in the same model. So this is the model of the equation, and these equations all lies in this model. So according to this model, the m value is what? For this equation, it is 1. This is also 1, and this is also 1. Okay, that means for multiple type of equation, same gradient is possible, isn't it? Why? Because they are all parallel to each other. That means they will move like this way and this way, and that equation also will move like this way and this way, but they will never what? They will never ever meet each other. Okay, that's what it means. They will actually never ever meet each other. Like they will keep on going that way, like, but the distance between them will always remain constant. They will never meet each other because like they're parallel to each other, and their distance never like changes. Their distance between them always remains a constant value because they have a constant gradient. That means for 1 unit increase in x, there will be a constant increase in y. For the gradient of means if we change x by 1 unit, the change in y should also be 1 unit. That's what the gradient means. That means to get same gradient from multiple or different equation is possible. Same goes for what? The integration. Now, we simplified all this equation by a single model of what? Y equals to mx plus c, isn't it? That means we introduced a constant here, isn't it? That means what? Instead of this constant, there could be any value. There could be 0, there could be 2, there could be k, there could be 5, there could be minus 10, there could be a, there could be anything. There could be infinity, any sort of value is possible. That's why like there will be millions of answers with this model. So in order to represent all the models, like generalize them, we place a C here. That means C is any constant. Like that means any sort of equation which satisfies this model, like is represented or is generalized to this model. Same thing is in like under integration. That means if we are integrating that dy by dx equals to n plus 1 x to the power n x to the power n, and we are moving this dx to the right hand side. So that means integration of like this dy equals to moving the constant front x to the power n and dx. We should get something which is y equals to n plus 1 remains here, and here x to the power n plus 1 divided by n plus 1. Like we need to increment the power by 1. This n plus 1 and this n plus 1 gets cancelled out. And what? There is a constant. So for that constant, we gave a c here because we don't know if there's a constant or not. If there's a constant or if there was no constant, as we have seen in the y equals to mx plus c equation. Because if we have equation y equals to, as we have like shown earlier, n plus 1, let's say we have a 5 here. Differentiating this and differentiating x to the power n plus 1 plus k, or y equals to n x to the power n plus 1 plus minus 100, anything you differentiate gives us the same exact result of y equals to dy by dx equals to n plus 1 x to the power n, isn't it? So that's why we have written the c here, because let's say we are formalizing it in this form model of y equals to x to the power n plus 1 plus c. If we differentiate them, what do we get? Again, we get n plus 1 x to the power n, isn't it? And the c becomes what? The c simply becomes like, it becomes 0, because here it's a constant and there's x to the power 0 multiplied with it, and differentiating x to the power 0 becomes 0, like just simply bringing that 0 in front, because c will remain constant and it is constant, it will remain by itself. That 0 comes in front, which is 0 times x to the power 0 minus 1. Like simply c is the coefficient and coefficient is a constant value. That 0 comes in front because the power comes in front and the power gets reduced, but anything multiplied with 0 becomes what? 0. So that means dy by dx is simply this answer. Okay, so that's why our actual result is introducing a constant there. Okay, so I will be giving a couple of examples. The homework should be to do these examples. So the first one is, let's say, fx. Remember earlier we have said that writing fx equals to y, or y equals to like y, instead of writing fx as y or y as fx, both are the same thing, but you have to write that considering fx is equals to y. Like in order to do this transition, you have to write it that fx is equals to y. Then we have to go, okay, y equals to 3x plus 3x squared, 3x plus 2. Okay, so this is the first example. So you have to integrate this. This is our initial, like, let's say fx. So instead of like fx, you will say that, okay, let's consider fx is as dy by dx. Initially, you will say this, then introduce your like terms here. Okay, then like continue with your workflow. Then we have this fx equals to 2 by x, y equals to what else do we have? Let's say y equals to cos x. Then fx equals to 4x cubed minus 2x squared plus 5x. fx equals to e to the power x, y equals to 2 sec square x tan x. Okay, and remember this sec means actually 1 by cos. Okay, sec x means 1 by cos x. This is actually the term. Let me check if that's correct or not. Yeah, 1 by cos x is equal to sec x. So use that concept if you need to find your terms. Okay, and tan x is equals to sin x divided by cos x. These are like some derivations. Okay, so you can use this to help you out. So I've given this just 6 examples. So if you need, you can simply go to, you can search online, like search Google to understand them. You can look through the books, try it by yourself. If you couldn't, inshallah, we will be like solving them in the next class. Okay. So okay then, inshallah, we'll be meeting in the, like we'll be observing and so going through the solutions in the next class. Till then, take care. Allah Hafiz. Assalamu alaikum.